Now, I want to come back to the topic of natural user interfaces. One of the most natural interfaces for people is human speech. And for the last 60 years, computer scientists have been trying to find ways to understand and recognize human speech. Now, in the beginning, when people first started tackling this problem, they looked at it largely as a pattern matching problem. And the earliest systems attempted to take the waveforms that came out of a speaker's voice and match them up to waveforms that they knew represented certain words. Unfortunately, that approach was extremely fragile, partly because everyone speaks differently, but also even a single speaker will often say the same thing differently depending on the other words or the context in which they're speaking. You've probably already noticed me doing that. Now, in the late 1970s, there was a major change in the way people decided to do speech recognition. This was work being done at Carnegie Mellon University. And the idea was to use a statistical modeling technique, in this case hidden Markov models, to make to really be able to take a lot of data from many speakers and produce more robust statistical models of speech. Now, that was a huge improvement. And over the last 30 years, speech recognition systems have become dramatically better than they used to be. They still make a lot of mistakes. But in limited domains, it's possible to do very successful speech interfaces. So, for example, in the United States, when I call my bank, I'm talking to a computer, I'm not talking to a person. The computer can answer simple questions about my bank account, or if necessary, it can connect me to a real person if I have a significant issue that I want to discuss. I'm sure you've heard of Apple's Siri product, which answers simple questions. Microsoft Connect has a robust speech interface that allows you to control the interface, and it even allows you to issue commands in the middle of games. Still, these systems have a lot of errors. And the error rates for arbitrary speech have been in the 20 to 25% range. Well, a few years ago, researchers at Microsoft Research and at the University of Toronto came together to develop what's another breakthrough in the field of speech recognition research. The idea that they had was to use a technology in a way patterned after the way the human brain works. It's called deep neural networks. And to use that to take in much more data than had previously been able to be used with the hidden Markov models, and use that to significantly improve recognition rates. So that one change, that particular breakthrough, increased recognition rates by approximately 30%. That's a big deal. That's the difference between going from 20 to 25% errors, or about one error out of every 4 or 5 words, to roughly 15% or slightly less errors, roughly 1 out of every 7 words, or perhaps even 1 out of every 8. So it's still not perfect. There's still a long way to go. But I think you can see that we have already made a significant amount of additional progress in the recognition of speech. Now, one of the problems that we've also been trying to solve for 60 years is machine translation. And again, in just the last few years, the combination of statistical techniques and big data have allowed us to do a much better job than we previously were able to do in being able to translate web pages or other kinds of information into other languages. For example, today, Bing Translate, which is Microsoft's translation system that comes out of Microsoft Research, Bing Translate translates millions of pages a day for users into their native language. It's an extremely heavily used service. Now, if I want to have what I'm saying be translated into Chinese, we can take the text that comes from my voice and put that through a translation system. It really happens in two steps. In the first instance, we take the English and we convert it more or less word by word into Chinese text. And I think pretty soon we may see that up on the screen. So what happens is we're basically taking the English text and pushing it through the translation system. We then have to reorder that text in Chinese because the word order in Chinese is not the same as the word order in English, to produce something that begins to resemble something that a Chinese speaker might say. So now we're taking the things that I'm saying and we're converting them into Chinese text. Now, the last step that I want to be able to take in this process is to actually speak to you in Chinese. Now, the key thing there is we've been able to take a large amount of information from many Chinese speakers and produce a text-to-speech system that takes Chinese text and converts it into Chinese language. And then we've taken an hour or so of my own voice, and we've used that to modulate the standard text-to-speech system so that it would sound like me. So what you see now is the result of that change. I'm speaking in English, and hopefully you'll hear me speak in Chinese in my own voice. Again, the results are not perfect. There are, in fact, quite a few errors.
结果并不完美。他们集体反复改错误。
There's much work to be done in this area.
在这方面有很多工作要做。
But this technology is very promising.
用这个技术很有希望。
And we hope in a few years that we'll be able to break down the language barriers between people.
数年后，我们希望能够打破人们之间的语言障碍。
Personally, I believe this is going to lead to a better world.
这我个人认为这将导致更好的世界。
I hope you enjoy the rest of the presentations today.
希望今天你喜欢其他的讲座。
Thank you.
谢谢。